Welcome to a zero-skip breakdown of DGCA Air Regulations Chapters 6 and 7. We are going to cover the exact separation methods and aerodrome vicinity rules you need for your CPL and ATPL operations. Aviation operates on the absolute discipline of numbers. Collision avoidance relies on a strict mathematical grid of rules, removing human intuition from the safety equation. This 3D grid demonstrates the protective bubble that ATC maintains around every aircraft and controlled airspace. You have vertical separation, lateral separation across the horizontal plane, and longitudinal separation along the route of flight. The exact dimensions of this bubble fluctuate. A 15-minute gap can compress to a 3-minute gap depending on specific trigger conditions, the classification of the airspace you are flying in, and the navigation equipment on board. Flying an aircraft involves managing a rigid, mathematically defined matrix of temporal, spatial, and visual parameters that guarantee survival. To understand separation, we have to establish who is legally responsible for providing it. That responsibility is dictated by the general provisions of airspace classification. Looking at this table, we see the highest level of control in Class A and B airspace. Here, ATC provides standard separation between all flights, regardless of their flight rules. Now look at Class C. This is a common DGCA exam trap. ATC separates IFR from IFR and IFR from VFR. However, they explicitly do not provide separation between two VFR flights. Moving down to Class D and E airspace, the controller's responsibility narrows further. In these sectors, ATC solely separates IFR flights from other IFR flights. The legal liability for collision avoidance dynamically shifts between the radar controller screen and the pilot's visual scan, based strictly on the letter designation of the airspace. This graphic illustrates the standard vertical separation minima. The baseline requirement is 1,000 feet of vertical distance. Once you climb above flight level 290, that minimum requirement doubles to 2,000 feet. There is a critical exception for RVSM-compliant airspace, where the separation remains at 1,000 feet, even above FL 290. Also note that performing a cruise climb is strictly prohibited in Indian FIRs. This side-by-side geometric comparison shows how lateral separation rules change based on the navigational aid. When using a VOR, aircraft tracks must diverge by a minimum of 15 degrees at a distance of 15 nautical miles from the station. Because an NDB is a less precise instrument, the rule compensates by requiring double the divergence. For NDB lateral separation, the tracks must diverge by at least 30 degrees at that same 15 nautical mile mark. The physical space required to guarantee safety is directly tethered to the precision limits of the navigation hardware being used. This flowchart outlines standard time-based longitudinal separation for cruising aircraft. Without frequent position and speed checks, the baseline separation is a standard 15 minutes. Time serves as a proxy for physical distance. If navigation aids permit frequent determination of position and speed, ATC can reduce that buffer down to 10 minutes. High-speed differentials allow for even tighter spacing. If the leading aircraft is 20 knots faster, the requirement drops to 5 minutes. If it is 40 knots faster, the separation shrinks to just 3 minutes. This profile view shows the specific rule for an aircraft passing through the level of another aircraft on the exact same track. A 15-minute separation must be maintained for the entire duration that vertical separation does not exist. In the terminal departure environment, clearances rely on 3 precise triggers: divergence angle, speed differential, and vertical crossover. This diagram illustrates Rule 1. A 1-minute separation is applied if the aircraft fly-arms hacks diverging by 45 degrees or more immediately after takeoff. This ensures lateral separation is provided almost instantly. This graphic shows Rule 2, addressing aircraft proposing to follow the same track. A 2-minute separation is required if the preceding aircraft is 40 knots or more faster than the following aircraft. This profile view details Rule 3. A 5-minute separation is mandatory when a following aircraft climbs through a preceding aircraft's level on the same track. ATC must ensure this 5-minute gap is maintained or increased, while vertical separation does not exist. Misidentifying a track divergence angle or a speed differential compromises the integrity of the terminal airspace. These hard trigger numbers are non-negotiable. Controlling an aerodrome requires interleaving departing traffic with arriving aircraft on the same runway. This timing is highly restricted. This text block outlines Scenario A for an arriving aircraft making a complete instrument approach. A departing aircraft may take off in any direction until the arrival starts its procedure turn. If taking off in a direction different by at least 45 degrees from the reciprocal, they can depart up to 3 minutes before the arrival is estimated over the runway. In scenario B, for a straight-in approach, the rules tighten. Takeoffs in any direction are strictly prohibited within 5 minutes of the arriving aircraft reaching the instrument runway. These panels show when separation minima in the vicinity of an aerodrome can be reduced. It requires either the aerodrome controller to have continuous visual contact with both aircraft, or for the flight crews to establish visual contact with each other and confirm they can maintain their own separation. The terminal approach area operates on a ruthless countdown timer. The inbound trajectory of an arriving aircraft strictly dictates the departing aircraft's legal window, down to the exact minute. A visual approach is an approach executed by an IFR flight when part or all of the instrument procedure is not completed. The pilot must have the runway in sight and maintain visual reference to the terrain. It remains an active IFR flight plan. This table details the visibility minimum acquired. For Category A and B aircraft, ground visibility cannot be below 2,800 meters. For a circling approach, it must be at least 5 kilometers across all categories. Furthermore, a controller cannot initiate a visual approach if they have reason to believe the crew is unfamiliar with the local terrain. This panel on the right shows the VMC daylight exception. In specific cases, ATC may clear a controlled flight to maintain its own separation from one other aircraft while remaining in visual meteorological conditions. This clearance is subject to 3 mandatory limits. It only applies in Class D and E airspace. It can only happen during daylight hours, and the specified portion of the flight must be at or below 10,000 feet. Shifting to visual separation transfers the ultimate collision avoidance authority directly into the cockpit. It requires perfect, instantaneous judgment of meteorological limits by the flight crew. Modern aircraft capabilities allow ATC to transition from time-based rules to precision distance-based separation, utilizing distance measuring equipment and global navigation satellite systems. This matrix demonstrates standard DME separation. Aircraft on the same track and cruising level require a 20 nautical mile baseline separation. That distance drops to 10 nautical miles only if the leading aircraft maintains a speed at least 20 knots faster than the following aircraft. This radar schematic maps out surveillance minimums. Within 60 nautical miles of the radar head, or ADS-B ground station, a 5 nautical mile separation is required. Once you cross beyond that 60 nautical mile threshold, the required separation immediately expands to 10 nautical miles. This diagram defines essential traffic. This occurs when controlled flights, both IFR and controlled VFR, are operating in airspace where ATC separation applies, but the appropriate minima are not currently met. When this happens, ATC must issue an immediate alert. While modern surveillance hardware safely compresses the airspace, the physical geometry still governs the risk. Crossing a geographic boundary, like the 60 nautical mile radar ring, instantly doubles your required safety margin. ATC is obligated to transmit essential information to departing and arriving aircraft without delay. This includes any significant changes in meteorological conditions, like RVR, wind shear, or thunderstorms, as well as the operational status of visual and non-visual aids. For your DGCA exams, the numerical constraints we've covered are the highest probability items you will face. To synthesize this, we use the master matrix. This quick reference card compiles the master matrix. It locks in vertical limits at 1,000 and 2,000 feet, lateral divergence for VOR and NDB, time-based reductions down to 3 minutes, and surveillance radar rings. Take a screenshot, study it, memorize these numbers, understand the precise triggers that alter them. These regulations form the absolute numerical framework that prevents catastrophe and makes modern commercial